our 5th episode.
I am Dustin, and the one who screamed at you is Kate.
I'm Kate. I'm very energetic today.
Yeah, you have to be. It's Friday. We changed our time so that we're not meeting on Saturday morning. We are now meeting in the evening. So we're all just drinking excessively water. We're drinking water. Oh, that didn't look good. Okay. Yes, water. And
if you're comfortable and want to do happy hour with us,
yeah,
we can be happy and talk about open science.
Mm-hmm. And spoilers, we're talking about open science today. And we're going to start just as like a quick outline of things that we'll talk about. We will introduce some of the headlines of, I'm sure you're all familiar with, the people who have broken science as we know it in psychology. And they all are all somehow affiliated with Kate and her university. It's all Kate's fault. It's not Kate's fault at all. And then we'll talk about some of the things some more broad terms that are related to open science. And then what are some practices that we can do as researchers? How do we participate in open science once we know what it is? Is it something that we want to participate in? We would argue, yes, open science is positive, and most of the people are very nice and welcoming. But we will talk about when tone and other things can be a problem and an issue. So Kate, was there anything that I missed on the overview of what we're talking about today?
No, I will add, just if you want to check out our episode 4 when it's live, that's going to be talking about authorship. If anyone is on research Twitter, they saw the tweet last week about 17 publications for people going on internship. That's since been debunked a little bit, but we did think that was a good opportunity to talk about writing, about authorship in graduate school, and tools and tips for learning how to become a more effective writer.
Yeah, so we invited 2 lab mates on, and they will have a post about that and be able to have you listen to that. And we all have different experiences coming into it and different struggles and strengths when it comes to writing. Spoiler alert, I'm not good at writing.
Spoiler alert, I've learned to be a little bit better, but as someone who identifies as a writer, I find academic writing really hard. So
it's different.
Into it, but I think it was a really interesting conversation. So we'll have a blog post up as well if you don't want to watch the conversation. But if you're looking for things and resources, we have that for you.
Yeah. But today, not talking about authorship. Well, maybe a little bit if we talk about open science and how you can be open about authorship and who goes where. But today, start with pulled from the headlines. Why can't I talk? I'm breaking down here. We'll talk about some of the big names that you may have heard. And I had sent in the original post, or the email that I had sent out had some articles linking to Bem, Daryl Bem, and him proving that ESP is real. And then talks about the reproducibility crisis and what is reproducibility and how it is related to science more broadly. So Kate, would you like to start with your Cornell alum?
Yeah, so I'm going to take responsibility for the Cornell figures as well as the Tilburg University figure. I have no association with Tilburg University, just to be clear. But I think the 3 people we're going to talk about today as an intro and entree into why open science are 3 people who I think are representative of different types of science, we'll say fraud, but also non-open science that's has not created, but unveiled a lot of problems that have been existing in the field for a while. And then that'll kind of lead us into like what we can do about it and why we think it's important, and why we think it's important for new grad students to incorporate as early on in their career as possible. So to start, oh, sorry.
I think just these are, there's a new kind of wave and push for open science. But as Kate alluded to, these are issues that had been talked about years and years and years before. And these are issues that had been apparent. It wasn't really until there were these three larger figures that came out with possibly more outright fraud that really put the attention back on these things.
Great, yeah. And so we're going to talk about the Kool-Aid man for slashing through the wall of something is very wrong, who's Daryl Bem. So Daryl Bem is this best described as wacky Cornell professor who became really well known for his theories, such as exotic breeds erotic, to talk about sexual preferences. And then his big theory that, opened up this window was his theory on ESP. So he published in the Journal of Personality and Social Psychology, so JSP or JPSP, which is a well-respected journal. This study saying that people could predict the future, and ESP is real. And this obviously feels so patently absurd that people are like, we need to look at this data. This cannot possibly be true. And so I think it's called the dirty test tubes kind of thing, where if something is off, you check the methods. So as people were looking into it, they're like, well, clearly there were cutoffs. They used the one-tailed t-test, things like that. Sorry, I forgot how to speak as well. Just edit over that part. Just edit in the right words. And they started to look critically. And there's this weird theory that I don't believe, but I think is fun, that Daryl Bem is actually a mastermind who purposely set this up because he knew it would start a conversation and would lead people to be like, wait a second, if you can publish this kind of result in a high-tier journal because you have name recognition and everything seems okay, then you're good to go. So this started opening up the floodgates of conversation about what are we doing wrong? Why was this able to be published? What kind of methods are being employed to let this kind of thing look legitimate on the face of it, even if we know it's absurd? So enter in a different figure who also brought this new era upon us. Diederik Stapel. Am I saying that name right? Okay, got a nod.
I think so. Yeah, Stapel. It sounds fun to pronounce.
Yeah, so Diederik Stapel is really interesting because he's the Tilburg University professor. So he is openly admitted to fraud. Dustin and I were talking earlier this week. He has a post where he talks about this process of manipulating data and outright just changing things. And so on the outside it looked correct, but it was all a massive fraud. Towards the end, he didn't even conduct these, or throughout these. So when he was a graduate student, he faked his first set of data. He had this cool finding, or he wanted to have this cool finding, and the numbers didn't, in his words, make sense. And so he edited them to make sense. And from there on out, he faked data, faked experiments. He took control over it. And throughout his career, he didn't let his graduate students collect data. He was always the person collecting data. And what's really interesting is when you get this from his perspective, it kind of sounds like he's planning a murder. The way he does it, he goes I knew it was wrong, but I couldn't not do it. And it's really dramatic, which I think is interesting. But then he was discovered to be a fraud. And one of the things that they realized is that all along, he was just so blatant about it, but he was doing it in a way that it could be believed. So he had this one M&M or Skittles experiment where he ate all of the Skittles himself in the first bit. And then he, built his data set off of what he thought would be a reasonable amount of Skittles to eat to see, in this experiment, was theoretically interesting in that it was like people who eat from a Skittle cup that says capitalist eat more Skittles. So he designed and conducted and was the participants in this experiment himself. And then he also made up this entire experiment, described it in great detail of an imaginary train station at this time. And the facts that he described were not facts at all. One might call them alternative facts. So that's kind of like other example where Bem might be someone who post hoc makes these changes. This is someone who outright like made up the experiment. And, you know, from the actual scientists now, we have Bem who's saying, I did everything right. And we have Stapel who later admitted, I deliberately did the wrong thing. And then we have Brian Wansink from Cornell. And he was, I think, around while I was still at Cornell. And so I feel responsibility for not, you know, showing up at his office and being like, stop right there. And I remember actually seeing posters of his work and hearing about it in the hallways of like certain buildings where I had classes. And so this to me is just personally interesting because I was there around that time, and here I was like learning about how to do science, and this like problematic thing was going on not too far away from me. So Brian Wansink is a professor from the food branding lab at Cornell, or I should say was, he no longer works there. And he had all these like really flashy experiment about how kids will eat more carrots if like you describe them as X-ray carrots to like give you supervision, like super great vision, not supervision. Or like things like that. Or his other really interesting one to me, if it was true, is that people don't notice how much soup they're eating. He made this like refilling bowl of soup. And so people will just keep eating and eating soup. And on the face of it, they seem really interesting. But then actually one of the, Dustin will get into this a little bit later, like data thugs or someone like went into it and started asking him for his data because they were like, oh, like we were looking at one of your papers and something in the methods, like it looks a little bit off. So we want to talk to you about that. And he obfuscated and tried to avoid these giving the data. And then finally he's come up to something like 20 retractions.
I think is
it 80?
It's like 60 from when I presented on this earlier. It was 61.
20 was low. I apologize.
Yeah.
It was 3 times that. So clearly like his entire body of work was a fraud. Brian Wansink admits partial responsibility. In December 2019, he posted this thing that I found particularly galling. He posted a blog post saying, hey, so I've had these papers retracted. Like, here are some like pitfalls and mistakes that here, like I've learned you can avoid. I still think like my body of work, like there's like really compelling areas, but he's been since like, I think internally there was an investigation. He's been put on leave. I think he no longer works for Cornell. But, you know, I think one of the things that gets talked about less or just isn't immediately on people's radars is there are grad students who worked for these people. And there are people who built who are trying to build their careers off of a mentor they trusted. And so I'll be honest, like I don't really know what happened to his grad students. I know with Stapel, the Tilburg University, they allowed the graduate students who defended on the fraudulent data, like they let them keep their degrees because the students weren't the ones who made the error. But I also can't imagine the kind of frustration or like the despair you would feel if you worked on this thing, like you labored over it and the person you trusted to give you the data gave you incorrect data. So I think a lot of times they talk about it as a higher level later on problem of like, what can you do to do all of the right things? But I really do think it's better to think, how can I operate on open science? How can I influence, like, how can I like have like upstream effects as a graduate student? But also saying that I know it puts a lot of onus on like the graduate student having to do the work. So we'll talk a little bit about that later, but just to say, I know it's really simple to be like, you should fight all of the like forces that are pushing against you to operate in the best way possible. But having also been in that position and felt that discomfort, not with like fraud, but like smaller things where I'd prefer to operate in an open science perspective. I realize it's really challenging and there are different power dynamics at play there. So that's kind of the opening for those three different kind of people who led to the field being like, oh my God, we have a really big problem. I'll hand it over to Dustin to talk a little bit more about that.
Yeah, so there have been lots of other studies that have looked at or had similar impacts on the field. And there's been lots of just like information out there and people creating their careers on this meta science and trying to then evaluate the science that is out there to see how are we doing things? Are we doing things in the correct way? But some things that I just wanted to define is you may have heard about the replication crisis or the replicability crisis or reproducibility, all those words. And really, they're all talking about the same kind of thing. And I think, at least in my thoughts, open science is a way to move forward. It's not going to be a cure-all, but it will get us on the right track, I think. It is going to be a lot of work, like Kate was saying, that there are these power dynamics and there are people who are wanting to do things the old way, which may be not as open in terms of like creating these variables or things like that. But I think one of the things so in defining, there's the replication crisis, which is this idea when you replicate a study, you take the same exact methods and there can be conceptual replications, there can be actual replications, but the same idea remains where you want to have the findings the same way or in the same kind of way that you would expect them to be from another population. And in psychology, that's not done a whole lot. Whereas I feel like other sciences, that is something that is more valued. So some mentors I've heard about, they're having their incoming students, their master's thesis is a replication. And that's all that it is. That's all that they'll do. Just to move science forward, to confirm these things that we thought we once knew, because that's a way to find out potentially things like Bem or Wansink or Stapel that they can't be replicated. And then there's this idea of reproducibility, which is, I alluded to it when we talked about R, but this idea that you can reproduce your own results. So it could be given the same data set, you can hand it off to somebody else, they can run the same analyses, and they will get the same results. So that's another way that you can combat these closed science and operate in more open science framework. So there was a paper that was put out in 2016 where like the stories that Kate talked about and some of the ones that I'm more familiar with are all in psychology because that's what field I'm in. But it also seems like that is where most of this data fraud or data manipulation is taking place. But this paper in Nature surveyed 1,500 scientists across different disciplines, from chemistry to biology to earth and environmental science, physics, engineering, and just asked various questions. And so I'm going to share some of those things. Let's see. So here you can see, this is a very zoomed in picture, but you can see just asking the question, is there a reproducibility crisis? That about half are saying, yes, there is something's going on, we should be addressing this. There is still a portion saying like, don't know or no crisis, but for the most part, we're like, yeah, something's up. Then we look at, I think some of the more compelling ones are looking at, have you failed to reproduce an experiment? So if we're looking here on this left figure, you can see that chemistry, it seems to be leading, at least in this sample, saying that between 80 and 90% of people have failed to reproduce an experiment. So this isn't even replication. This is just reproducing. So you have the data, you have the paper, and you're trying to walk through and reproduce those same results. And they're saying that they failed to reproduce the experiment. And then psychology is down here in other. We're not nice enough to be able to get our own category, I guess. But still, there is, I mean, this number should be 0. Across the board, we should be able to reproduce the things that we do no matter what. And then some of the other, I think this is just a different mindset that oftentimes, at least how science seemed to be done, is you publish something and then you wait for the citations to roll in and then you build upon that work. You're not looking back at it. Once it's done, it's done. And I think having this new framework on how we should approach science is thinking about reproducibility as brushing your teeth, that it's something that should be ingrained in the steps that you're taking when you're doing science. And that's why I think things like R and some of the stuff that we talked about during that session and some of the other tools that we'll talk about, it's to allow for your studies to be reproducible. And it could be, reproducibility could take a number of different avenues. It could be like in this example where you're reproducing somebody else's, but it's also doing your own stuff. So there's only been one paper that I've done that was not 100% open. And I think it would be difficult for me to go back and know all of the individual steps that I did if someone asked for me to reproduce those results. After that, once I transition into using R, I could reproduce anything that is asked, which is refreshing on my part. I take that as a comfort. So I think that is one thing just to say, that this isn't just a psychology problem, that this is across the board. This is a way that science is thought of, and we need to shift it on a more major scale. But by taking in some of the things that we're talking about today and in our other meetings, that you can start moving the bar forward for yourself, and then hopefully setting those goals for others by talking and being open about these things.
And just to add, like, one of the things that I think helped change my mind about it is talking about it from like a chemistry physics perspective. I think there's sometimes a bit of defensiveness when someone looks at your theory and they don't, like, when you see someone's trying to replicate your work, or at least test your theory or build upon it in the field. Like, maybe not always, but I think there's sometimes a defensiveness of ideas. In chemistry and in physics, like, a big mindset is we want people to be able to replicate our findings, because then that strengthens our theory. And I think sometimes that gets lost in the way I think about it. And so if that gets lost in the way I think about it, then I imagine that that's probably a wider problem. That's not something I just kind of came up with out of nowhere. But if you want to build a strong and popular theory, you want it to like go through rigorous testing so you feel good about it. And also, like, I would hate to, at the end of my career, have all of my work be invalidated because I didn't do a strong enough job testing it and building a good case. So I think from a we want to gain knowledge perspective, which I credit that thinking to Dustin, you're the first person who thought of that.
Yep.
You're the first one who brought it up in our conversation earlier this week. But also in just I want to feel confident that the work that I'm doing is strong work, not just for my own, like, I want to be a famous researcher in my circle, but because, like, I want to think that the work that I'm doing is impactful. And it's not impactful if it's not true. So it's like simple, but I think sometimes gets lost in like the chase for funding or the chase into looking like you're doing really cool work, but like if it's really cool but fake, then why bother?
Yeah, and I think that's what pushed Bem and Stapel and Wansink. I don't think I can ever pronounce his name correctly, but Kate assured me that he shouldn't get his name pronounced correctly. So,
Doesn't deserve it.
yeah. But I think we're going to be saying some things in how we think science can move forward, but also recognizing that we are operating within a system that at this point in time doesn't necessarily value these things as much as we would think that they should. And so having fewer publications potentially because they are open or because you did a registered report or certain things that some universities might not see that as valuable as somebody who has published double your amount or whatever. But I think it goes back to what do you value? How do you think that we acquire knowledge? I was a philosophy major in college, and my advisor constantly brings that up. So we talk about philosophy every once in a while. And this idea of how do we know what we know? And I think there's, I'm going to misremember it, but if you are trying to identify, there are like black geese exist. Isn't this the thing? Yeah. Okay. And you're not going to go and you see a lake full of white geese, and you can't use that evidence to say, well, there are no black geese. You have to look to invalidate your theory in order to gain knowledge. And so that's the idea that Kate was talking about and bringing that up. One of the things I just wanted to bring back up with this reproducibility is in this study in Nature, they said data on how much the scientific literature is reproducible are rare and generally bleak. The best known analyses from psychology and cancer biology found rates around 40% and 10% respectively. So 10% of cancer biology analyses are reproducible and 40% of psychology. So we could say, yeah, we're doing better, but it's still not where we think it should be.
Yeah, and it's such a, I mean, when you think of it too, like, I think sometimes it feels easier to understand things from like a medical perspective because you get so much money pumped into medical studies that, and they're often for really like high mortality diseases. And if people aren't being as ethical as possible and as open as possible, then like money is wasted and like there's unnecessary suffering. And so I think from and you know, we could talk about another day. We're mostly talking from a social science perspective, but there's also a real problem in the medical community with the pressure to publish the pressure to publish positive findings. So I think that's, you know, it's hard when there are these pressures, but also when you think about it from the perspective of like people who are looking for help and people who aren't in our field who want to benefit from our knowledge, like it just like ethically also feels like you can't not be open science oriented. So if we'll like move on a little bit from that, but just to like super make the case of why it is important. It's important for all of these reasons and 1,000 more that we haven't brought up.
And we won't have time to, so we'll probably have more episodes on us talking about open science and some of the ideas that we have. But we want to, for now, give you tools to practice open science. And what does that look like for a new researcher? And so some of the big pieces of open science and open science practices are basically in the name. You want to be very open about what you're doing and having things accessible to others, have things being open and free and available to everybody, and basically telling people what you're going to do before you do it. And I think this is, when we think about science, that's what we think it should be. And at least from my perspective, that when we were taught how to do science way back when, we had the scientific method where you have a hypothesis. And what is the scientific method? Why can't I remember it? You hypothesize. That's good. That's great for me I'm going to edit that out.
Starts with generating a hypothesis, but also doesn't it start with looking at past data? I don't know if they have that in the like middle school thing. If anyone wants to jump in here in the comments, but
Yeah, it's like, please review all past literature as a middle schooler.
Yeah, do a literature review.
Yes. But it's going to be, having a question, observing data, looking at previous data, doing literature reviews, making a hypothesis, having a question, then conducting your experiment, and then collecting. I am now, yeah.
I know.
Collecting data, analyzing your results, and then reporting them. And you tend to operate in those steps, and they build upon one another. But throughout this process, you are if you're in a class, you're going to be reporting to your instructor, these are the steps that I'm going to take. And they're like, okay, go ahead and do that, because you're in high school chemistry and they don't want you to burn the building down, which would be great not to do. And so then you proceed, you go down those steps, and then you report the results. And it's very transparent and open. And a lot of times when it comes to psychology, you are sitting, what we're doing, you can be sitting at your computer in your home, and you can have all of your data. You can put up a study on MTurk or wherever, collect a bunch of data, and then you can analyze it. And you don't have to talk to anybody. You don't have to see anybody. And then you can submit it to a journal. And there are supposed to be, you're going to then get 3 random reviewers who will know however much they know about your particular study, and then it could be published. And you don't have to be transparent about any of the processes that you did. And I think that's what Stapel definitely did. And to some extent, there is this idea of the Garden of Forking Paths, which is a paper that we'll probably put in the blog post. But I think it's very interesting we have our question, and then we analyze it the way that we wanted to. And then we think, well, it didn't work. So maybe if I didn't control for age, maybe there is this age effect that's in there that I'm not accounting for, that's totally washing out my results. So you put age in, and then you're like, well, maybe it's only for girls. So then you only look at a subset of girls. And then you look at, oh, maybe it's only for post-pubertal or pre-pubertal. And you start making all these decisions, and it ends up getting to one very specific outcome along this large decision tree of potential results that it could have been. And you keep going, you keep chugging along until you hit that significant result. And then you're done. Then you stop. But you don't go back and reanalyze everything else. And that is the Garden of Forking Paths. It's I can share it really quick so you can see what I'm looking at. But having this, you have the data, and then you start moving down one of those paths, you make a decision, and then you keep kind of chugging along until you get to p less than 0.05. But all of the other options that you didn't choose, or maybe you did choose them and then you found it was non-significant, so you back up, and then you go down another path, and then you back up, and you keep going until you get that significant value. And so this is by Gilman and Loken in 2013. I would suggest checking that out. It's very interesting and provoking. But I think, if I recall, this is a very long paper. So take your time with it, or just look at this figure and you're like, I got it. No need to read it. But walking through these steps, this is not something that you would do in your science class. This is something that with the pressure to publish that significant result and get those publications leads to these types of analyses. And when you're doing them, it does not seem like you're being malicious or you're p-hacking or you're doing questionable research practices, but you're going against you're slicing your data in such a way so that you're capitalizing on chance, basically, within a statistical standpoint. And by being very transparent, if that's what you want to do, and if you want to explore the data, be very transparent about that. And that's okay. That you said, I tried all of these analyses and they didn't work. This one did. So I'm going to talk about this. But saying that you did everything else is what we would want, so that somebody can reproduce your results, because you're going to have people who may want to build a career on the stuff that you do. And if you are slicing the data in such a way and potentially finding spurious results, somebody's not going to be able to make a career, and it's not going to move science forward.
So what can you do? And like, what I feel like a lot of this sounds like really like, don't do this, and this is really bad, and like I stand by those. But what can you do to start being more mindful, and like what are the tools available to practice open science? So enter amazing Brian Nozick and the Open Science Forum. Nope, I always get it wrong. I say Open Science Foundation, Open Science Framework. That's it. Third time's the charm. Sorry.
There you go.
So I had never heard of OSF before I'd come to the lab, but it's amazing, and it's a great solution to so just a quick like show of like hands or things in the comments if you want to just say like, do you know what pre-registration is, and do you know what OSF is? And you can just say yes or no. Okay, we've got a thumbs up. Cool, thumbs up. Wow, this is really cool. Great. So great. We are talking to people who already know what they're about. So has everyone, just to add another thumbs up, have you pre-registered or used OSF before? Okay. Cool. All right, so we'll talk about, I'll hand it back over to Dustin to talk about like pre-registering and introductory to OSF, because he is someone who uses OSF for more than just pre-registering, which I think is great. And so he has the most experience and time spent with it.
So OSF is the Open Science Framework, and Brian Nosek, it's all free. It's a wonderful resource, and we'll post. They recently tweeted out steps to pre-registering and getting a project going on OSF, which is really great. And so we'll link to that, and you can take a look at that. But I thought it would be good. I can share my account, and so we can take a look at that and what I've been working on. Let me make sure nothing is. Why would there be anything weird on there? That'd be bad. So here you can see that we have. When you log in, it has your dashboard, and so you may have nothing on it, which is okay. But you can use this. It's basically a very fancy and research-oriented Dropbox. So one of the things that I'll also link to is I gave a talk on open science in our brown bag over the fall. And I used this as a platform where I could share all of the information that I had gathered. And so you can see I have the actual presentation here in PDF form that you can look at, and a lot of the stuff that I had talked about already is in here. But you can use it for a number of different things. And I think that by itself is really great. But what the main goal of it is to pre-register your studies. And let's see, This is one of the things that I'm working on with Kate, and this is where it's at right now. This is in the like pre-data collection. Well, this one's already collected, but this is where it will look when I have pre-registered it. So all you need to do is create a document. It can be in Word. There are a lot of, there are a lot of different templates that you can use in how to pre-register, but basically you just want to let people know what you're going to be doing. So focusing on what measures you're going to be collecting, what the data analytic plan is going to be, and then how really those are the two main things. So you need to get as detailed as possible, thinking about how many participants you're going to have, and what are the steps that you're going to take. So here you can see I have an introduction, which you can include, but then I have my hypothesis. We have the methods that we're using. We have a great looking figure, the measures, and then when it gets to the data analytic plan, being able to incorporate code is great. So that once you are set to publish your results and you submit it to a journal, you can include a link to this pre-registration and say, hey, all of the stuff that I said I was going to do in the paper, I said I was going to do that 6 months ago, and I followed all of those steps. And then reviewers will be more confident in the results that you do have. And some reviewers don't ever check this. Some reviewers do, but you're able to see what is it that you said that you were going to do, and then how did that pan out later on.
And just to add in, sorry, really quick, you don't have to use an R Markdown document.
No.
So if you're still getting acquainted with R, or like you're not quite comfortable yet, that's not something you have to do. There's a lot of flexibility in what you put on OSF, but the best would be having your methods, and it's also how science is supposed to be done, right? Like you're supposed to do the write-up before you're supposed to write your introduction, your data analytic plan, like all that stuff before you actually do the analysis. So it's front loading your work anyway. So I think a lot of times one of the criticisms is that it like drags out the process. But in reality, it's actually a really good tool for two reasons. Like one is if you do all this work and there are no findings, you can just do a really quick write-up. It doesn't have to be a full paper. Then you have that on OSF, and it's also, you're contributing to fighting against the file drawer effect. So that's a big plus. And then it doesn't feel like, like time sunk. And then the second is if you do have significant findings that you want, or findings in general that you want to publish, then you've already done half to most of like a big chunk of the work.
Yeah, and it's taking what you would do after data collection and just putting it before it. And it makes for a very interesting conversation, and just you're engaging with it, I feel like, a lot more. You're really thinking about what are the steps that I would take and why would I do that? Why would I need to control for age? Or why would I want to include XYZ as a covariate, or dichotomizing the data? And it makes you really think about the steps that you're going to take before you take the steps. And then what you can even do is, well, if that doesn't work, what am I going to do? And then being very mindful and thoughtful of what future you will do is very beneficial. Then you can say, like, I said I was going to do this, and these are the steps that I took. It's just very comforting. And I see.
Yeah, I was just going to say, Emily had a question. Yep. Actually, the OSF example is for data that was already collected. So you can definitely do that.
Yeah, pre-registration is really, there is no set way that it has to be done. And I think that's what can be very overwhelming at first, is your advisor might say, oh yeah, I've heard about open science. I listened to these 2 graduate students talk about it on YouTube because they watched us, and they're like, we need to do this. So go pre-register. And you can Google, and there can be lots of different things. It can be very simple and straightforward. I think there's a website called aspredicted.com.org, something like that. And it's just very structured in the way that you do it. Or it could just be a Word document like we had, where you're typing out what plans you're going to have, what you're going to do. And this would be before you kind of look at the data, before you can have some basic descriptives, but you don't want to be conducting t-tests or correlations or anything beforehand. This will be completely blind to the data, basically.
And actually, since we have 10 minutes left, originally we were going to spend some time talking about data thugs and like some other things we can do. But I think maybe instead we could talk a little bit about registered reports. Does that sound okay?
Yeah, no, I think that sounds good. And well, just to sum up OSF stuff, you have the pre-registration. Then after you have published, what is encouraged is to have your code available. And I think that is really beneficial. It makes you think more about what is in your code and how clean it is. This could be R, this could be your SPSS code, because as you point and click, it will spit out output, and you can copy that so that your work can be reproduced. That's what you want to have that eye towards, is being able to reproduce your results. And having your data open potentially. Then what Kate was saying, there is this, I think it's Chris Chambers. I think he's the main motivator for a registered report. So we'll do the thumbs up again. Registered reports, have you heard about them or not?
Well, we're waiting to get
We got
feedback.
one.
And Chris Chambers also, he wrote 7 Deadly Sins of psychology. But
So.
we'll put the link up to that. But that's something, a book that I own and have skimmed, but have not read all of, but plan to this summer. But I have heard it's a really great book, and my skimming has shown me that it has a lot of good ideas in there. So that's Chris Chambers.
A registered report is basically a pre-registration to the 10th degree, like turned up to 11. And the way that it's currently structured is only for new data. Right now, some journals are working on trying to get this same framework applied to already existing data, like a secondary data analysis. But right now it's only for newly collected data. And you basically pre-register all of the steps that you're going to take, and you submit that to reviewers. So you have your full intro, you have your full methods, and then what is really interesting is you actually write your results, and you put in your analyses that you're going to do. And then you have in parentheses, if this has like a beta above a certain value, or if this is a statistically significant finding, then I want this clause to go after it. Or if it's not, then I want this to say this. So you basically write the entire paper as like a choose your own adventure. And then you don't write the discussion just yet. You submit that to a journal, and editors review it. This is before you've collected any data. So you have 3 reviewers who say, well, I think those methods are okay. I would suggest you add in asking questions about sexuality, or I would have you ask questions about depression and anxiety if you're going to get those things. And so then that comes back, and then you're able to tweak the results. I mean, not the results, you're able to tweak the study design in such a way that it will make the claims stronger, hopefully. And the paper is accepted on principle. So, but even before you run your study, your paper is accepted to that journal. And then it goes through, once you collect the data, it then goes back to the reviewers, the same 3 reviewers, hopefully, and they just double check to make sure that you followed everything that you said that you were going to do, and then you have your paper accepted. Right now, I think there's about 200, maybe a little bit more, different journals that are open to accepting registered reports. There aren't a lot in clinical right now, or like developmental. I think it gets really tricky just given the nature of what developmental psychology studies. But I think that's one of the steps moving forward, is having this registered report where you take away this need for having positive results. So even if you find nothing, if everything comes back as null, you still have that published.
And yeah, I think that's kind of the gold standard. I'm kind of surprised that that's not, I guess, you know, people have always assumed best intentions, but this forces you to follow through. So I had not heard about it until probably the last year. And it just seemed so intuitive and really exciting that that was what people were doing. And so I think maybe and hopefully that's the future. I know it's like much harder to do a registered report because you do need to do all of that work, but at the same time, like, it's all the work you would be doing anyway, just in the right way. But also, you know, you get extra credit for doing a registered report. I know for OSF, if you pre-register, some journals will give you a badge. Is that correct?
Yeah, there are some journals that are trying to be like, I don't know. There's like a little icon that goes on your paper. That's like, it was pre-registered, like, good job. So they're trying to make it more fun, I guess. I don't know.
Make it like Pokemon Go, but for papers.
How would you do that?
I don't know. It was like, it was an immediately thought, and just, there was no filter from brain or from mouth to brain to mouth. Anyway,
there you go. All right. Yeah, we got there. We were on that journey together.
But like, you could collect different badges. Like, each journal, you should collect a registered report badge and an OSF badge. I'm starting to think it through a lot more. And then at the end, you have to like MMA fight the other people in like the PI gym. This is getting absurd.
It started making a lot of sense, and then it turned to violence very quickly. And I don't know if I was
the first day of dark thoughts.
Yes.
Any depression.
Yeah. There is, for these last few minutes, there is also this idea of a preprint, and this is there is sci-archive. It's PSYARXIV. And there are like bioarchive is a big one for biology, I'm guessing is what that is. But this allows you to post papers that you have submitted to a journal. A lot of people, the idea is the day that you submit to a journal, you also post it to sci-archive as a preprint, which means people can read it. They don't need to be a reviewer. They don't need to wait for a reviewer to tear it apart in order to see it in a journal later on. So you can go on sci-archive and you can see people posting things from today, from yesterday, about research, which is really great, and like journal articles that they're submitting, which speeds up the process a little bit, because getting a paper published takes a very, very long time, which you can refer back to our past episode where we talk about publishing papers.
And sci-archive's really cool. I found this paper, like, really exciting paper that I'm excited to, like, I wouldn't have even heard about it. I wouldn't have it in my, like, I've already kind of, it's helped form some ideas I'm planning on doing. I also think it puts the onus on you, because you know it's a preprint. You're a little more, like, for me at least, like, I was a little more skeptical and critical of the methods going in, because I'm like, oh, it hasn't been, even though it's by researchers I really like think highly of, it hasn't been pre-vetted. So maybe like not saying, like, sometimes, you know, it leads to not including things that the original authors might have wanted to include in the process of getting published. I think it's also cool from like a research gossip section to see what's changed in the final version from the sci-archive. But I just really appreciate having that up beforehand, because it's really helpful. It's been really helpful to me. This was like a cool paper on pubertal measurement that I got really excited about and made our whole lab read. And I'm just glad that I got it when I did. So I really appreciate that. And that also, I think, might alleviate some pressure in like getting your work out there. And can you put a preprint on a CV? Like, is that, I don't know, just from your perspective?
Again, this goes back to like open science practices and how familiar people are with open science. But there are some people who would see that almost as valuable as like a in-press journal article, because it is to some degree. You're just waiting for 3 random people to say, yeah, I liked it, or no, you misspelled this word, and all these other things.
And no paywall.
Yes, it's all free. It's really great. And it's really great to see what researchers are posting to sci-archive. I think that speaks to who is doing open science, so it can also help you navigate as you're trying to see who you want to talk to and what are some communities that you want to be established within. So you can start seeing who's posting there, who's tweeting about it, things like that. Was there, and as you can tell, Kate and I can talk about this a very long time, and we'll probably have many more episodes or meetings or whatever these are called about this, in talking about different registered reports or the publishing process. Why should we say that 3 random people have better say than other things? And there's a lot out there. Data thugs, we talk about stat check, talk about all these things.
I'm excited too. So if you have any questions, you can, type them in as we're finishing up, but you can also email us and we can go over that in like a blog post before if you're so excited you want to hear about it before our next talk. It can either guide our future calls, or it can also just lead to our discussions internally, and we can talk about that later. But in the meantime, we'll head to future directions. Have you thought yours out yet?
I started when you, like 2 seconds ago, said it will inform a future episode. And so I think you can start right here.
Okay. So my first future direction is right after this lab call. I'm going to have some of these Reese's Pieces. They look really good. And the second is that one of the things I think a lot about with like social sciences, it's it's informed, you look at our environment, the social environment, and I've kind of been on the mind that I should keep my Twitter as like science or like lighthearted or science as possible. But I want to be more mindful of like social justice issues, because they inform the research and they inform the work we do and the participants we study. So that's something, I'm going to spend a lot of time this summer on. Today I was recommended a book that I might do a book club on, which is mindfulness and social justice. And so that's something I'm going to look into, and I may have further updates on if it's really good. It seems like it will be invaluable. So that's it.
Yeah, I haven't done a whole lot this week, so I have very few future directions. I do think, given the current climate and everything that's going on, just recognizing that we are all trying our best and we're all doing what we're doing, and recognizing that we're all human. And I think with Kate too, it's one of those things that realizing who I am and how the things that I say can impact others. I think just being more aware of that is what I'm going to continue working on as a future direction. But in a more lighthearted, you can go watch Nate Bargatze. He's a great comedian. He has a stand-up episode called The Tennessee Kid. I think it's that. Yeah. he's wonderful. He's very clean and just like great delivery and just an all around cool.
Like physically clean, or like you can watch
Yes.
with your children?
Both.
Oh, okay.
Yeah. His dad was, I think he has another special, because his dad was like a clown and a magician. So it was like how he was raised by a
Double
clown,
threat.
which is, yeah, it was really interesting.
That's my backup.
What?
Clown.
Clown.
Just clown.
Okay.
I'm gonna do it for free. We also both like John Mulaney a lot.
Yes.
So if you're looking for some mindless comedy, I actually, as you said that, I was like, you know who's also mostly clean as a comedian? John Mulaney.
Yeah.
He comes on whose show? Hassan Minaj show, and he explains popular things that like it's like popular white people things or like American culture things, and it's really funny. So I personally enjoyed that. My favorite was Barbra Streisand. So would recommend that if you can find it.
Yeah, John Mulaney's great. Did you see his, Melissa Villaseñor on SNL did impression of him as like him doing a master class? Check that out.
Okay.
That's hilarious. Yeah.
Cool. All right. Otherwise, we'll have our next meeting next Friday at 5 p.m. So we'll see you guys then. I think we're going to do R. If you have any preferences of not R, or like if I would love to do R. I'm sorry, I'm not projecting. But if there's something else you want to hear about, we can put that in line. But we're also going to do something on science communication in 2 weeks, I believe.
Mm-hmm.
So if you want to start thinking or talking about or asking questions about how to start in the sci-com world or start public communication of your work, then we'll have that on tap. And you can also email us beforehand if you have certain topics in that area that you want us to touch on.
Follow us on Twitter. Mine is Dustin Harridan. Kate, what's yours?
At K8MCC.
Underscore MCC, right?
Oh, underscore MCC.
Yeah.
Yeah,
Don't
that's
forget
right.
the underscore. You'll be following some random Kate McCormick.
It's probably better.